Hello, hello. Hello, everybody. Hey, Arshia, how's it going? Thank you. I do love this background. It's pretty awesome. Hey, there we go. Looks like it took a second for LinkedIn to get through, but looks like it's there now. Hi, everybody. How's everyone doing today? Howdy. I've always liked howdy. From Relay. I don't think I know where that is. Let me look that up. Is he in North Carolina? Hello, everybody. Dominican Republic, eh? That's pretty cool. Hello. Okay. Yeah. So any questions? Loving all the greetings though. It's really nice to see everybody here. Virginia. Nice. Your screen is blank. Well, that's not good. Hopefully, well, I mean, I hope that it's blank for nobody, but hopefully you're the only one if it is blank. Any questions, anyone? Your aim is to become an aspiring data scientist. Well, I can certainly help you. I'm doing great for humanity. I really appreciate that. I would love to do even much more for humanity in the future, but I would definitely like to. Um, German or German. The I just linked this time. I just linked my video in like the post or the description for either the YouTube live or the LinkedIn live. I just have like my data science pathway or machine learning pathway, and then the link to that so that you can go off to that video and see in the description of that video has all of the links if you want the links, or just watch the video if you want to watch the video. So I found that easier than putting like a million links like right here. It's just go off to that video, and that's my roadmap. Stacking and multi-layer stacking. Yeah, stacking is pretty cool. It's stacking is basically like you just have kind of interlock models. So you could have, say, like, um, what's an interesting one, or or not an interesting one, I suppose. Um, I'm not sure if it's I believe this would still count as stacking, although it's really just a weighted average, which is the most common one. Generally, what the best machine learning model is for most types of problems, as in not that it's going to work most of the time, but most of the time you have like an SQL database and you have like rows and columns. If you're making a machine learning model based off of those, most of the time the best model is going to be some sort of a weighted average, or at least that's not necessarily the best model. But what we usually find as the best model is generally a weighted average of multiple predictions or of multiple learners. And so those learners are like, say, like a random forest, a gradient boosting model, and more complicated stuff that you may or may not have heard of. And same with me, there's a lot of different models. But stacking, you can do all sorts of like, you make a model here and then you feed that into this other model and you do like averages all over the place. That starts to get confusing, as that probably sounded confusing. Not that it was the best, not that it was the best description, but that's the idea. You kind of use multiple learners, and most of the time you just take like a weighted average and say like 30% of the prediction goes to this random forest, 30% goes to this boosting model, 40% to something else, and then you kind of merge them together to get some final prediction. Literally a data scientist. Yep, I have in the description how to do that. Today, can I tell you about some of the advanced statistics required for data scientists? Um, so advanced statistics, I would honestly just kind of count that as machine learning. Like statistical learning is the term they might use because like if you were to go to university and like do math or statistics or something, even computer science for many places, my hat is not in the right spot. um, if you were to go for math and statistics and get a degree, then the first couple courses would, generally you don't say that the first few are advanced, although they're often some of the most popular or most commonly used techniques like confidence intervals and hypothesis tests. They teach most of that in the first couple courses. They're very helpful as well. So whether you want to call that advanced or beginner, I don't know, but they are very helpful. I was doing some analysis on stocks recently, and again, I don't recommend it. I don't recommend, especially right now, if you're familiar with the stock market right now, I would be extra wary about doing some analytics and making some informed buys. But essentially, yes, hypothesis tests and confidence intervals are very useful, and that's not generally considered advanced. Uh, Beginner, yeah, stuff like expectation, random variables, and then that allows you to learn. So, say like look at linear regression pretty closely. Look at like an ANOVA, so an analysis of variance. You have couple other courses that you can go pretty deep into. You can go further into regression, so like advanced linear models, or sorry, what is that one term I'm missing? Probably some people know it, but I can't think of it. Um, Generalized linear models, which is like linear regression is the most, and then logistic regression, and then some other ones. Yeah, I'm not going to go too much further into that, but just to say like a couple words quickly, like um, what is it, like Monte Carlo simulation, um, or like the integrals, and what is the other one? Markov chains is pretty advanced as well, which is pretty cool. Okay. Oh man, I got lost in the chat. Okay. Stanford Online on LinkedIn posted that on 15th of June. Right. Thank you so much for saying this here. Yes, I was reading your comments before, and I couldn't keep up with it because, yeah, I was trying to figure out where they said that or who said that, and I could not find that. So I will look at that right after. And June 15th, 2 days from now. Thank you so much for keep telling me this. I really appreciate that. Keen to drown into the topics. Please start. Yeah, I mean, go ahead, start. I have that. I have that LinkedIn, or you're from LinkedIn, so that not that it actually matters whether you're from LinkedIn or YouTube or not this time, but in the post, just in the description, it should have my video to the pathway. I would recommend starting there. Is it possible to get data analysis scholarship from Udacity Nano Degree Program Certificate? A data analysis scholarship. Is that something? I don't think I know what that is. If they mean some sort of a scholarship for the Udacity Nano Degree Program, they probably have something like that, some sort of free or cheaper way to do it. But other than that, I don't quite know what you mean. Hello, hello, hello. Lots of highs. Can I remove the cap? Why would I? It's a Python hat. That would just be silly. Um, Tips for entering the data business. I mean, learn data. Honestly, like if you're trying to get into it, there's a lot of different pieces. To be honest, there's SQL to work with relational databases. There's also, of course, no SQL databases, but I wouldn't really worry about it too much. Programming, you need to be really good at programming. A math or statistics degree or computer science degree is very beneficial, of course. Um, if you want to get like a master's degree, that it's getting pretty advanced, and like I'm talking about several years in the future now, but not a terrible idea. Um, yeah, but mostly just to self learn. Like I have the video pathway in the description, and those are all the courses that I flow very well together in order. You'll learn pretty much what you need to know without going too in depth into anything that's not relevant. And that's my best tips. Yeah. Um, and I got lost. Sometimes this thing just jumps around for some reason. Okay. Wait. Yeah. Which languages are more important to be? Okay. Why do you keep saying to remove the cap? Like that's like 4 messages in a row. Wow? It's a Python hat. Why would I get rid of that? Which languages are more important to be a data engineer? Python or R? Data engineer, Python. I don't think there's really any data engineers that are in R. R is an analytics language. It's not so much for moving data. It's more so for using data. Of course, it is a programming language. It you know, you can, of course, do pretty much anything and most of them. But Python is general purpose. We've kind of adapted that to be good at data engineering. R is it's a stats language. It's pretty much a stats language, which isn't really data engineering most of the time. Of course, you might, but more so, data engineer often implies moving data, and it doesn't always imply performing analytics on data, which is why you'd usually use not even necessarily Python, although Python is relatively common. Still, stuff like backend languages that are common, um, Java, Scala, um, C sharp in some companies. Uh, there's a lot of different choices, but those are some of the most common ones. Internship. Okay, I have to see what you wrote before. Is it possible to get a data analysis scholar? I don't quite know what you a data analysis internship. Yeah. Okay. I'm gonna assume you. Wait, I wasn't doing the. Totally forgot that I was supposed to be doing this and clicking things so that you could see what I was talking about. Okay. Starting now, I will do that. Is it possible to get a data analysis? They fixed their answer to internship, I believe. So, is it possible to get a data analysis internship from Udacity Nano Degree Program Certificate? Yes, it is. Their thing is pretty in depth, and their certificate's pretty good. It's also a little bit expensive, and so you have to weigh your options there. There's some cheaper options, significantly cheaper options, but it's pretty good. It's not in my recommended pathway. It's still, I have reviewed it. And if you want to know my thoughts on it, then you can check out my. I don't think I've reviewed if there's a data analytics one. I've reviewed the data science. Maybe I'll work on that. But yeah, you can. In general, from all of these sorts of XYZ certificates, like Coursera, Udacity, Udemy, any of those, the answer is most of the time like yes, you can get an internship from these. They could be very beneficial. And internship generally implies you're in some sort of school degree already. And so that is actually like the perfect combination to get an internship and even just a full-time any sort of job is generally some sort of academic degree still in this field is going to help. And then these courses on the side are very beneficial. Of course, you don't necessarily need a school degree, but they're helpful. Hello. Okay, which is better for ML deployment, Streamlit or Flask? Flask. Flask is better for machine learning deployment, at least in it's better for making websites in general and making complex backend design. Not super complex. Usually you'd step up to something bigger like Django for it, although Flask could do, it would do just fine. Streamlit, although I think they're actually making a fair amount of changes to Streamlit and making it faster and better. It's probably, I might be a little bit out of date, but I would most likely say Flask. I don't know if maybe some people in the chat have thoughts there. How can I join data science? I don't know what you mean by join. If you mean get a job in it, I've got a pathway that you can check. Sir, in which language a data science enthusiastic should do data structures and algorithms, whether C++ or Python? So if you're asking, should you choose between C++ or Python? Oh, okay, yeah. So I see. So basically, yes. If you want to learn data structures and algorithms from a theoretical point of view, so basically, ignoring the fact that you're trying to use these in a programming language to do something in particular. And I think you probably noticed I'm trying to look at my actual camera more than the screen. Um, so if you are trying to learn data structures and algorithms from a theoretical point of view, so like runtime analysis, the complexity of algorithms, and well, the data structures and the different operations they perform, and just about them in general, what they do, why you might need them, how they're implemented, um, then yes, generally something like C++ or C, anything where you have explicit pointers, and explicit allocation of memory is, in my opinion, and most people's opinions, yes, a more solid foundation and really understanding how this stuff works. And then you kind of learn the history of how that evolves from C and C++ into Python and Java, where you don't really start thinking about pointers anymore. They still exist, but they just abstract that away in that kind of that dot object or dot operation. In classes, you have x dot or list dot append or something like that. Um, and so yes, you would get a more solid foundation if you did it from C or C++. If you are trying to maybe learn a little bit about it, and you have very little coding experience, then something like Python could be helpful. Like, hey, this is a dictionary, and this is what this does. Um, you're probably not going to learn about how a dictionary is actually implemented, which is through like a hash map. But yeah, so if you are really really trying to learn it, then C and C++. If you're just trying to use it and get used to it in Python, then Python's fine. Hello, Percy Jackson. I have a good feeling that you waited the 8 minutes for me to get here. How's it going? Um, what separates a senior machine learning engineer from a junior machine learning engineer? Well, kind of in any sort of a job, as you get more and more senior, you get generally more and more in an advisory role. And so that would tend to happen. A junior machine learning engineer is still, I mean, it's up to what the job says, of course. But just talking about what a junior machine learning engineer is most of the time, well, you're going to be hired based off of those kind of abilities to make basic machine learning models. So, like, hopefully, you could talk about linear regression, logistic regression, and maybe into the tree-based models like random forest and gradient boosting, that type of thing. And so, maybe they have some type of a problem at the company, and they'd get a junior machine learning engineer so that you could do those things. If you want to talk about it from the company standpoint, then a senior machine learning engineer is nothing more than a junior machine learning engineer that's a little bit older, maybe has been at other companies in junior machine learning engineer roles, or at the same company and has kind of evolved. It really is just about seniority in terms of a title, and sometimes that comes with different. I don't want to say privileges, but um, kind of architectural design decisions. Like, hey, you get a team of a senior machine learning engineer might get a team of junior ML engineers and kind of guide them in the right direction. So that's what I would kind of say was at my last and final internship. I think that made a very clear design or uh, gave me a good perspective on. I was a junior ML engineer, not necessarily meaning I don't know anything and you're just kind of walking into it and you're a complete junior. But you are kind of the one like doing most of the coding. Like you need to be the one trying different algorithms. But a senior ML engineer, they still might be trying things and doing things themselves as well. But then they might kind of organize you and be like, hey, we'll meet every few days and be like, like, I see where you're going on this. Have you tried this? And so they're kind of just, one level higher and they understand all the stuff that you're doing most of the time. Now, that's the one perspective, of course, in terms of seniority. I believe the actual answer to your question, which I figured out halfway, was probably not the answer that you meant, although I wanted to keep talking about it anyway. Because that's kind of like it is important to think about it as both perspectives, and I'll give the other one shortly. like in terms of a job, like why would one be a junior versus a senior? That answer is that. But in terms of say the skill level of an engineer, so like how do you like why is one a beginner machine learning engineer versus one is kind of an experienced? So instead of saying junior and senior, which is correct in terms of the job market, but for regarding skill level, well, a beginner machine learning engineer, still I would hope you kind of understand like um, how to train a machine learning model and um, some of the details behind some of the important ones. So, like a linear regression, a logistic regression, um, like why that's linear. And so, why a linear regression is drawing a line through points, and a logistic regression is drawing kind of a linear decision boundary, marking different classes. So, that type of thing. Um, but the skill set that basically makes one better than the other, well, one I would have to say is just about a vast amount of knowledge, in that you can mostly assume that a junior ML engineer, has a decent, you know, me, small to medium amount of information regarding different things. So, like maybe they've made a couple projects in computer vision, and they've made some neural networks to tackle these computer vision problems. They put that on their resume, and then hey, we need you to do some similar things. They'll grab that person, interview them, and if they've answered those questions enough, then sure, you're on the job and you're a junior ML engineer. But to really set apart the skill level, I'd say you have to know like a lot of different things. Um, and although I do know there's a video out there that says that Andrew Ng does say that like, hey, you should pick one of these areas like NLP, computer vision, kind of like traditional data like stuff or traditional statistic stuff. You should kind of try to pick one of these and then go really hard and specialize. Just the same conversation that everyone says about you should specialize. But at the same time, it's almost hard to really specialize in machine learning and data science without going without learning a lot of different things. Um, because, well, first of all, there's many types of data, and in a company, like even in one table, like I remember seeing, some database tables that have so many different columns, and some of them are text and some of them are videos. Of course, do you really store a video in a column? Not really, but you would store a link to that to the AWS link to that column. And so, you know, maybe a junior machine learning engineer would kind of say, "Oh, I don't know how to work with this text data. I'm going to completely remove that." But then some sort of a senior machine learning engineer might be like, "Hey, no, I know a little bit about natural language processing. I know the little bit extra that it takes to kind of incorporate that text column into a model. Maybe it helps, maybe it doesn't. And I'm not necessarily saying that you should be using all variables. In fact, that's kind of a recipe to overfit sometimes, or even just underfit and confuse the heck out of the model. But the point is that there's a lot of different things that are out there, like learning rates for neural networks, um, kind of understanding, how do I say it? Yes, the underfitting versus overfitting through penalization. What's the word I'm forgetting? Not regularization. So understanding what regularization is and how you can manipulate models to do fit more, fit less. How you analyze the performance of models. There's a lot of different ways you can do these things, but there is a few fundamental skills. And so I would really master the couple fundamental skills, and then you can probably be a junior ML engineer after that. And then to be really senior and to understand all these different pieces, you just have to learn, like read papers, watch courses, um, and yeah, that's my answer. Okay, how could we go deep into SQL? Uh, First of all, I don't know how deep you have to go into SQL. If you can select some data, you can do joins and um, y- what's the other one? Subqueries. If you can do joins and subqueries, do where clause and get some data, then honestly, that's probably enough for most positions. Of course, there is some jobs out there that you need to be like they're wanting you to be really heavy in the SQL skills, and it is, there is definitely a big difference if you're talking junior and senior. There's a massive difference between someone that kind of knows SQL and someone that can build out these absolutely massive queries in the most optimized way. If you do want to get really really into it, I there are books that kind of go over everything. I forget the one that's yeah, I forget. But there's definitely, if you pick up like a relational databases book, they'll kind of teach you all about pretty much everything there. There's practice, of course. There's lots of practice questions, even on like Leet Code and those types of websites. Sorry, I didn't click your question, so that's not even your question. um, that's your question. Sorry. Um, great. I lost my train of thought because of that. Even on the websites like Leet Code and that type of thing, there are certainly practice questions for SQL. But to be honest, most of the time, I feel like you should just kind of learn the basics up to joins and subqueries, practice that, and kind of looking at the relational design of like you get a new table and you look at the schema and how tables relate to each other through the keys, and practice how to get different types of data through that. Past that point, I'd have to say, not certainly, but most likely, you're kind of wasting your time by just absolutely mastering SQL when you could just be using it to do things or to interview with companies, and you'd probably already have most of the skills that they'd be looking for anyway. Um, okay, something just jumped around. There we go. Hello, my name is Gray. um, I am doing well. Your question is how to become a research scientist. There's a lot of different terms for that, and I don't quite know exactly the one you're referring to. You'll have to be a little bit more specific for what you mean by research scientist, because people research a lot of things. Of course, data scientist is an extremely general word as well. Like, what is a data scientist? They study data and they do things with data. But especially research scientist, in this kind of a context, I'm not totally sure. Sup, Jeff? um, oh, hi, Marty. Sorry, yeah, it's been 19 minutes. I don't know if you're still here and waited for that, but hi, Marty. How's it going? What you need to be as a beginner to data. Sorry, what I need to learn as a beginner to a data engineer. SQL, Python, Spark, I would say are your best friends there. So try to get up to learning big data and Spark through PySpark, and don't just skip right to that. In my opinion, kind of learn some of the basics, like make sure you're a solid programmer. Um, you SQL, I would say learn SQL right now, and then just for fun, like some of the maybe some statistics concepts. But mostly stick to just moving data. SQL is a big one to do that, and then PySpark or Spark to move it really quickly at big amounts. Which programming language is the best for data science, Python or R? Check out my YouTube video that I posted recently, and you'll enjoy a nice little skit between Greg with a Python hat and Greg with a Tommy Hilfiger hat, because I don't have an R hat because I don't like R very much. So kind of already said it, but they're both good languages. R is great, especially for basic statistics or even complex statistics things. But if you're doing something like ANOVA, like analysis of variance, or anything in the generalized linear model family, like linear regression, logistic regression, and confidence intervals, random intervals, and like p values, that kind of thing, R is great for that. It's all in Python as well. But that's really the only reason I'd stick with R is if you already know it and you don't want to learn a different language. That's fair. Um, if you're choosing between the two, I would certainly choose Python, but either one, take a pick. How to improve yourself as a data scientist? Yep, keep reading, keep practicing on Kaggle and just solving problems in different ways. Keep learning about different algorithms. Keep looking at people's say Kaggle notebooks and seeing why their technique is better than yours, see how they're analyzing their model and how it's um, yeah, how they're proving that it's better. Um, and just keep reading, keep learning, keep practicing, keep doing things that are interesting to you, and you'll get there. Want to become an ML engineer? Where to start? You already know Python. Perfect. I would definitely recommend my pathway in the description of the of whatever this of YouTube, yes, or LinkedIn. You're welcome. You're welcome. You are a, I think that's database administrator, right? And no knowledge in programming. Can I still switch my career to data science? Then how should I start? What courses and languages required? Um, could I please answer this question in a detailed way? Um, okay. Um, yes, I no, I'm sorry, I don't have time to give that a detailed way to do this, but seriously, I have a pathway. Check the link that I sent in the LinkedIn in this LinkedIn post. Check out that video. Go to the description and see my recommended pathway. That's my suggestion. Yeah. How Power BI is important to data analysts? I mean, it does business intelligence. What is business intelligence? Well, yeah, that's a very general term, which is just like, yeah, it's as general as data science is. But it's sort of kind of its own type of field, business intelligence. And I sort of kind of don't feel like it's super, super necessary. Um, but as a data analyst, yeah, maybe people will say it's really common, and it is somewhat common because it's a tool that's been around for quite a while. Um, but I feel like kind of just SQL and even just like strong Excel skills would kind of override that. Uh, I'm sure people would disagree with me on that, but I don't think that you need to learn Power BI. But in general, how's it important? It's going to help you bring value to data, and there's a very streamlined system that they have associated with it to do that. How to be good in Kaggle and build a good profile? Well, build a good profile by being good at Kaggle, and being good at Kaggle. Well, yeah, what I just said, I already answered that, and I know that you've already asked the question kind of before I answered it, and I'm just seeing it now. But yeah, like go to people's Kaggle notebooks and be like, hey, this person's evaluating this model like this, and they're using this feature like this, and if you don't understand why that makes sense, then go read about it online and be like, why are they using pictures? Why are they using this for pictures? Or why are they doing this weird transformation of the data? Yeah, you just keep learning, keep reading online. What is PySpark's future? Very strong. PySpark will have a very strong future. It's incredibly fast now, and it can move data very, very quickly. The syntax is almost nothing. Like to do very complicated transformations, the syntax is basically nothing, and you just have to understand what it's doing. You don't even necessarily have to understand how it's doing it, although it's not a bad idea. PySpark has a very strong future, and it will. Um, I mean, sure, anything can override it, and like I'm not trying to say that you know this Spark is going to last 100 years or whatever. But the concept of what it's doing, utilizing multiple computers using their fast memory, like RAM instead of like a hard drive. I can't see anything that's able to beat what it does because yeah, like that's how we use computers. That's in big companies, like that's what they're doing. They're using many computers like in parallel or in parallel as much as they can. Um, and before we used like hard drives to store and move around data, always reading and writing to disk, but that's slow. PySpark says, hey, just give me a bunch of RAM or main memory, which is very fast, and it will do its job in there, which is tremendous. Like it's extremely powerful, and for the user, like it's not complicated. You don't have to write these really weird rules for to tell it what to do. It already knows what you want to do based off of very common patterns and transformations, like a join, like a map, like a filter. Um, Its future is strong. I appreciate that. Perfect. Hello, hello. Are there jobs in machine learning after bachelor's, or one needs to do a master's for that? Check out my video where I talk about if you need a master's or not, and I have my full kind of thoughts there. But as a 2 second summary to those that aren't going to watch that video, essentially, I say that any higher level any higher level of academic education will be tremendously valuable. Um, but that doesn't necessarily mean that you need any of those levels. I do believe that a bachelor's in particular is tremendously valuable, and then you might start to see, kind of a drop off and also a massive gain at the same time for getting a master's or PhD. What do I mean by that? Well, I mean that I think you can get a lot of the positions after just a bachelor's, but many of them claim they need a master's or PhD. Some of them actually do, and so you might get a massive gain out of getting a master's or PhD. Um, those are my 2 second thoughts. I think that is a fast way to do data science. I don't think it's necessary because, again, something like PySpark will do data science tremendously fast. And doing it in C++, I don't know the specifics, but I doubt you're going to get that much of a gain by writing it strictly in C++ versus doing what PySpark or something is doing behind the scenes. And stuff like NumPy, NumPy, pandas, that type of thing. That's all going to convert to C, or mostly it's going to convert to C and C++ anyway. So it doesn't, it's not as valuable as it used to be. And even then, it's faster. But I mean, how fast do you need things to do? Like, how fast do you really need your code to be? It's already done like very, very quick in massive proportions. And so, of course, in companies, like, what are they gonna? They're pushing the limits out of everything. Like, companies like Google and Facebook or whatever have like these massive, massive amounts of data. And so, of course, like, just a little bit faster for them is, it's huge. It could be millions or billions of dollars. Who knows? So yes, there's a lot of value out of being faster, but for the most part, generally speaking, this stuff is fast enough, and so it's just not necessary. Is there any problem with doing data science in C++? Say if you're already good at it, if you like coding in it and you're really comfortable in it, you could do stuff quickly. It's fine. Like, sure, go for it. Do what you want to do. But it's in terms of learning it, that you don't really have to, in my opinion. Okay. Pursuing data science, is there any chance to get 98% accuracy? If yes, is this the best? Okay, this is a great discussion because it illustrates a couple things. So, firstly, accuracy is a bad metric. Accuracy meaning the basically the proportion of right answers. So, like, the right answers divided by all of everything. This is a bad metric because it doesn't look at the distribution of different classes. So, for example, if you had like, if you were trying to make a model between cats, dogs, and zebras, and you had 5 pictures of zebras, you had 1,000 cats and 1,000 dogs. I think I did cat, dog, and zebra. If I didn't say that at the beginning, I'm doing cat, dog, zebra now. If you had 5 pictures of zebras, 1,000 pictures of cats, and 1,000 pictures of dogs, very clearly you have way, way, way more pictures of cats and dogs than zebras. You could get a 98% accuracy on that model by just having something that's really, really good at seeing cats and dogs. And you might have gotten it might be absolutely horrendously bad at seeing zebras. And it probably would be if it was trained on that data. And so you could get a 98% accuracy, but that doesn't provide you any value, because if you're truly trying to make a model that can be good at calculating all of these things, um, then or at measuring all of these different things, at saying, hey, that's a zebra, that's a cat, that's a dog. Well, if it doesn't know some of the classes in there, like say a zebra, or if there's more of them, if it doesn't know some of them, well, then that's what the model was supposed to do, and so it's crap. um, so 98% accuracy, that doesn't help you. What does help you is some metrics. like true positive rate, false positive rate for all the classes, or like F1 score, which looks at kind of a combination between the true positive rate, false positive rate. And I'm not going to talk about all the metrics. If you want to understand really fully what I'm talking about, check out my video that's about, I think, 30 minutes long, where I go over binary classification metrics. I have that in my YouTube video, and that'll go over all of them. And at the very beginning, it'll kind of explain why accuracy is not phenomenal. So why is it so common? Why is it? Why am I here saying that accuracy is a bad metric when it's used all over the place? Well, that's because it's simple. It's an easy mathematical calculation, and it intuitively does actually, tell us something that we are often interested in. We as humans talk about accuracy very commonly, like just for doing just about anything. About if there's any sort of ability to do something wrong, then accuracy is usually the metric we talk about. How many times did we get it right? How many times did we run this experiment in general? You take the proportion or the fraction there, and you're left with an accuracy. I missed the board when I was throwing darts. I missed the board 5 times, and I got I threw it 10 times. I got a 50% accuracy. We say these things, but you have to use metrics that are actually valuable when you're talking about really getting into the nitty gritty of making a model that does something. So I'd recommend checking out my video on that further. Um, yeah. So to answer this question really specifically, there is definitely a chance to get 98% accuracy. It may or may not be meaningful. If you had, just cats and dogs, if you had 1,000 pictures of cats, 1,000 pictures of dogs, you had a 98% accuracy. That must be a good model because since the amount of pictures of both is very similar, uh, then a 98% accuracy means by default you are good at predicting both. And so, yes, you could get a 98% meaningful accuracy. You could get in a different situation, a 98% unmeaningful accuracy. Um, and there's other metrics that you might want to look at. Okay, how is the cloud computing important to the data analyst or data engineer? Is it a needed requirement? It's something that you may be able to learn on the job, and they may or may not require that you know it previously. In terms of actually doing implementation, like on the job, providing value, I'd have to say yes. And it's just going to keep growing and growing. These companies like Google, Microsoft, Amazon are going to, maybe one of them really takes over the cloud, but um, probably they're all going to keep fighting in unison and getting bigger and bigger and bigger and having more and more on the cloud. And so, yes, like doing any sort of processing on the cloud is, it's going to be everything. Like most companies now are basically advised by almost everybody to, hey, instead of dealing with this stuff yourself, it will be cheaper and more flexible and safer for you to do, like put all of your resources or most of them on the cloud, and make Amazon and Google and Microsoft deal with that instead of you. Okay. Does Kaggle profile help and how to get good in Kaggle? Yeah, hopefully I answered that earlier. I'm not going to talk about that again. Are there jobs for a data analyst in USA for an Indonesian? Well, companies aren't allowed to be racist, and so the Indonesian provides no context in terms of any sort of decision making. Companies are not allowed to really think about that. I mean, sometimes they're forced to think about it in a way that actually, brings multiple groups, diverse groups. But in terms of like saying no to someone in a different group, they will not be doing that. So I'm going to ignore the Indonesian part. It's a good question, but no. Data analyst in USA in general, of course. So the answer is simply yes. Is it possible to become a data scientist for a basic Inc. level programmer? Basic, I guess that just meant basic. Is it possible to become a data scientist for a basic level programmer. Yeah. I mean, no, no. I would be very, very good at programming to be a data scientist. It's very important. It's a very important skill. His PySpark profile. Is that a thing? I'm looking up if that's a particular term that I haven't heard. PySpark profile. Spark profiler is a thing. Methods and functions. Um, Custom profilers. I don't actually know what this is. It may or may not be very valuable. My Spark skills are not absolutely top notch. Um, so if there's some sort of other skill there, then possibly. I can't really say. Good, good, good. Is this being recorded? Probably. Yeah. 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 It'll be on YouTube. It's probably on LinkedIn permanently as well. I can't read that, but good point. Sorry. Um, is it recommended to learn data structures and algorithms as a beginner to get a job as a data scientist, or should we only focus on data science concepts to get a job as a beginner? Uh, as a beginner, so sometimes data scientist interviews may or may not ask a lead code or data structures and algorithms or competitive programming, whatever, all the same thing type of question. They may or may not ask that question. As it ramps up in difficulty and more competitiveness, they will generally ramp up the difficulty of their problems. At the very basic level, they might not ask anything at all, but I probably, they what they most likely would do is make sure that you know the concepts at all. So, like, why is a dictionary like faster than searching through an array at times? Um, yeah, yeah, like general lists and arrays and dictionaries and linked lists. Hopefully that you've seen it before. But in terms of being really like phenomenally good at it, some jobs still might ask that, but not all of them will. And it jumped around weird. There we go. Uh, get good grades. uh, that's that's 99%. Got to be honest. If you're talking about academic institutions, sure, you can talk about. I think Waterloo has this AIF thing where you have like a form and you explain different things. Of course, that's like 5% or whatever it may be. But almost all of it, I have to say, just if you want to get into any institution at any level, grades, grades, grades. Uh, Greetings from Chile. Yes, hello. Where do I get data and build my home environment to handle the robustness of machine learning? I don't know what that means, to be honest. Um, where do I get data? I get data from wherever I need data. So if I was looking at stock data, like securities. If you want to look at that, then you'd have to figure out the websites. You'd have to go search websites and be like, "Hey, there's this table here." And then you'd use like pandas, their read table function, um, or like Beautiful Soup or something like that to get data from websites. And yeah, it's a little bit more complicated that way, but most of the information on the internet is not stored in this absolutely perfect database. It's scrambled in like Wikipedia and random tables, and that's fine. You just have to figure out how to get that. In terms of building my home environment to handle the robustness of the machine learning, um, well, my computer's decent. It has a NVIDIA 3060 GPU, which can handle, small amounts of computation. It's not robust by any means to big data, like big data. But, a good computer at home is beneficial often. Advantages slash disadvantages of using AWS versus Azure for cloud. Um, I can't say that I'm so versed into the specifics of AWS versus Azure that I can answer that properly. I would ask someone else that question that is really, really working in those both of those or has worked in many of those many times. So I'm gonna just pass on that question because I don't totally know. But in general, I wouldn't really worry about it too much. They will both be fine. I promise that. Um, I don't like Julia. I don't know Rust. I know it. I know its existence, but aside from its existence, I could say very little. I don't like Julia. I've looked at the syntax, and this it looks ugly to me. Maybe that's just because I'm so used to Python, but I've used other languages too, like C, C++, Java. Um, pretty most of them, and I don't like Julia's syntax. It just looked funny to me. Rust, I thought people did like it, but I'm not sure. In terms of the advance, I can't really say. The best thing to do is kind of just forecast from a graph. Sorry, my throat's getting dry. um, yeah, the best thing to do is just kind of forecast through a line and see like if this has been growing in popularity for such and such long and it's continuing to grow. I mean, that's the most likely prediction, but you never know. Do I think that data analyst is the first step to becoming a data scientist? I think it's a first step, or at least it could be a first step. I'm not sure if it has to be, but it's a really good idea. Sorry. Mm. Yeah, it would help for sure. Getting out in the field and getting a job in data analysis is yeah, it would provide value for sure. What do I suggest after watching Andrew Ng's deep learning course to land a job? Good question. So I would read, uh, most likely like more advanced topics because you've kind of expanded your horizons, and if you understand that stuff decently well, then you kind of know what's out there. But if that's kind of it, which is that's where I was for quite a while actually. You're probably at the point where you should read papers in object detection and computer vision and natural language processing and go out and do things and practice and solve real problems. You're past the stage where it's kind of like just kind of smooth watching videos, trying to understand some concepts. You got to get advanced and start to really see what people are doing in the field. And you're really close to providing some real value. And definitely start applying to companies at this stage. Like I think you always should. But after the deep learning specialization, you know, y- you're kind of ready to get out there and start doing some interesting things. Is it recommended to learn data structures and algorithm? I already answered this question, so yes, it is. I mean, I'm pretty sure I answered that question. Should we only focus on? Oh, did I actually answer that question? Whatever. If I didn't already answer that particular question, yes, you should probably learn data structures and algorithms as well as data science and machine learning concepts. Yes, both of them are important. What frameworks? PyTorch or TensorFlow. Pick one, stick with it. Pick one. If you don't like it, choose the other one. TensorFlow is more common, I think, but they're both very common. Can you explain Spark? Is it software technology or it, it's software? It's a framework, sort of. Um, it's an abstraction to something called MapReduce in, and it definitely knows what to do with the hardware to do this appropriately. So it's more than just import PySpark, and it's a framework in Python. For example, it's not just like, hey, there's some existent code out there, and you're going to download that to your computer and use that. Yes, it is actually at the same time, but it is more of a way. It is software that tells a computer or a group of computers how to best utilize their resources and manage things so that it can do what you want, which is SQL like operations most of the time. So like a join. So like applying some function to each of the columns. Um, so like filtering rows out that you don't want. So any sort of select clause. When you get big data, you have a lot of rows. It's usually best to store that on multiple computers and have each of them kind of doing their own thing rather than everything on one computer and it's trying to figure out how to manage everything. So you have one computer in Spark, and it's one computer that says, "Hey, all of these other computers store this data, store like partition, say rows of the data, and you know I'm going to tell you what to do, and you're just going to do it." PySpark is kind of, or Spark is the whole kind of system code telling the computer how to resource allocate its resources so that it can do that for a user. So like for me, like if I wanted to, or you, if you wanted to go use Spark, it would look nothing different than importing a library and using that library. Unless you want to get into how you actually, how much resources you assign the computer, it would look pretty much the same as just download some new library from PyPy and then get going with it. And it's not difficult either. It's not overly confusing from a user like writing the code point of view. What about a career transition? 30 plus years in all levels of IT is transitioning difficult. 30 years of IT. I've only been alive for 23. Can't be that hard. um, no, honestly, I think you just have to learn some things and apply, and that's about it. A lot of skills there clearly, a lot of industry experience. Take some online courses, follow the maybe follow the pathway that I have in the post, that link, the video that I have. Maybe take those courses if you want, get those certificates, and yeah, it should be good to go. You're very welcome. You're very welcome. What should I be most proficient in as a data analyst? Excel, BI tools, SQL, Python. How much knowledge do I need in all of these to get a data analyst / data engineer role? I would place least importance on Power BI. I would place a lot of importance on programming in SQL and Python and Excel, of course. It's not a bad idea. My Excel skills, to be honest, aren't very good. It could be a little bit better, absolutely, and it might provide some value. But for the most part, I'd have to say that programming is just taking over everything, and that's in SQL to do relational design coding, and Python itself to do just stuff. It's a general purpose language. It does pretty much anything. So I'd say that Python and SQL are probably the focus, or are even are for just a data analyst. Yeah, learning statistics and doing analytics and transforming data through like Python and SQL. And if you want to do a bit of Excel and a bit of Power BI, or maybe if you really like it and you want to go really into that, then of course. But that's my answer. More videos on live project. Okay, yeah, I'll try to do that. Yeah. Perfect. Oh, I love to hear the word that it's motivating. I'm really happy to hear that. Hello, sunshine. Should you start the Google ML course? Sure. Yeah, you could. Can someone help you? No, not. I don't know. I guess you mean someone else. Do ML engineers put models in production as well? Yes, of course they do. They certainly do. Not always, but you might. Hello. Hello. Okay. Anybody have some info? Okay, again, doesn't look like you're asking me. Amazing. Thank you so much. Glad to hear it. You're very welcome. Hello. How often does a data scientist, how often a data scientist has to do with unsupervised machine learning? I don't know, like pretty commonly. I'd say supervised learning is more common for sure. Doing something like a regression or a logistic regression or making a complicated machine learning model, I'd say that that's probably more common. But I've been asked or I've seen opportunities to perform stuff like clustering, like k-means or deep scan, or definitely if you're going to talk about recommendation systems, all the big companies have recommendation systems. Um, and that counts as unsupervised learning. The really, really common kind of helpful unsupervised learning stuff to help supervised learning, like a PCA, some sort of dimensionality reduction technique or transformation, comes up all the time as well. It's almost just kind of built in us to, when we're doing supervised learning, to use some unsupervised learning to help in that. Okay, sweet beans. Sweet beans, eh? Uh, yeah, I just wonder if my desktop can handle the processing. Maybe not. It doesn't have to. Perfect. I'm so glad to hear that. You're very welcome. Have a hard time dealing with Hadoop if I learn PySpark. In which course will it be enough? Honestly, I you don't have to worry about it. There is a big data specialization. A couple of them on Coursera. The University of California one I saw goes into really, really big into Hadoop, so that could be very beneficial. But more so, it's about Spark than Hadoop nowadays. Can you also make a video on stock exchange forecasting / prediction in NLP? That let me process that. Stock exchange, yes, for stock exchange forecasting using natural language processing. I don't think that makes any sense. So are you saying, so just to really break this down, you're kind of suggesting that we use natural language data in order to build a model so that we can predict stocks. Normally you use stock data to predict stocks, and it's even that is pretty sketchy. But doing it with natural language processing is, you know what? To be honest, I've thought about this. I'm not trying to say that you're crazy by any means, and I love these sorts of interesting questions. But to be honest, this is actually possible because uh, probably the biggest movement of stocks comes from people talking about stuff. And maybe you know this, and that's why you're saying it. Um, or maybe I'm just going further into something which is very interesting. But essentially, stock moves because or stock moves in big pushes, generally because of news forecasts. If some really big news, or YouTube video comes out, like Fox News or one of the big American stock or not stock news reporters comes out and says all these things, which they do every day, and especially right now. But that it actually does come from language data, both video and people talking, and just written news reports and blog posts. So yes, theoretically, you actually could incorporate the movement of people are saying it's all about to crash, and so you're predicting it's all about to crash, or maybe somehow it's the reverse. I don't really know, but no, I will not be making a video on that because that's tremendously valuable. And not no, sorry, it's not. It's not that I won't be making a video on it because it's tremendously valuable. It is a tremendously valuable problem to solve and to be really good at, and it is unlikely that I would be able to do something that's very good at that. Um, and to be honest, if one was to, they would start a company, uh, and they would, or at least some company would buy them, most likely. Can you connect with me on LinkedIn? Sure, I accept all connections on LinkedIn. Great, I'm very glad to hear that, Darlene. Okay, I think I am at the bottom, so that's where I can probably sign off. It's been an hour, so that's about how long I like to run on. Okay, thank you so much, everybody, for stopping by. I really appreciate it. I hope you got some valid information. Again, if you're just looking for a data science or machine learning pathway, check the video I have linked in this description. You should see that. Sure. Can I share some knowledge about reinforcement learning? It's a really freaking cool field, and the best book for reinforcement learning is definitely the Reinforcement Learning book by Sutton and Bartow. Right now, it's the second edition. Sorry, I'm just trying to answer these quickly. Might be a bit out of context. Today, deep learning and AI have been popular since the contribution to genomics and artificial neuron for plastic biodegradable method. Do I have thought? Not really. Nope. That's nope. Sorry, I can't really get too far into that. You're very welcome. You as well. Okay. All right. I'm signing off. Thank you so much, everybody. I will catch you next time. Bye bye.